Hi guys, today we're going to look at writing a quadratic equation in the vertex form. Now we have already established the fact from our last video that all quadratic equations have a standard form which is known as ax squared plus bx plus c. Now today we're seeing a new terminology and it says vertex form. Now the question is asking us to write this quadratic equation, which is that is in the form of ax squared plus bx plus c, in the vertex form, which is a open bracket x plus h close bracket square plus k. Now the vertex form formula here varies. Some persons use x minus h and some persons use x plus h. In another video, we're going to explain why there's a deviation with the minus versus the plus. Okay. For this video though, however, we're going to work out this question using three methods. First, we're going to look at the completing the square method, then using the formula method, then we're going to look at the diagrammatic method. Alright, now for the completing the square method. Now the aim of the completing the square method is to get our quadratic equation from the form ax squared plus bx plus c, have it be equivalent to a open bracket x plus h squared plus k. So what we're going to be doing is finding, or there's already an established creative way that you can transform this expression into this expression. So you're going to transform it from the standard quadratic form to the vertex form. Now the first step that we're going to do is to group the terms that have variables. So we have x squared plus 6x, group them, plus 9. After we have grouped, next, if the coefficient of the x squared was not 1, then we would have to factorize. However, in this case, there's no need for us to factorize. Then we're going to quote unquote, not exactly, but in essence, we're going to expand the bracket by saying x squared plus 6x plus the square, open bracket here, let's put a square there, close our bracket, put back our 9, and whatever we add here, we will have to subtract it here also. Because remember, we have to keep this equation the same. So whatever I add, I will have to subtract it. Now, what goes in this bracket here? Whatever goes in this bracket here is going to be half of the b term or the bx term. So what is half of 6? Half of 6 is 3. So we have 3 squared here, which is going to be the same 3 squared here. So if I add 9, I'm going to have to subtract 9. So now we're just going to keep the terms that have powers of 2. So we have x positive 3 plus 3 all squared, carry down back our 9 or carry our 9 minus 3 squared, which is 9. And we can go ahead and simplify. So we get what? X plus 3 all squared plus 0. So we know that. So therefore, in this form, we can say that our a is equal to 1, our h is equal to 3, and k is equal to 0. Okay, for method 2, we're going to use the formula of h is equal to b over 2a, and k is equal to 4ac minus b squared all over 4a. Now, in order for us to apply this formula, we first have to establish what our A, B, and C terms are. And remember from our last video, we said that by comparison, A is equal to 1, B is equal to 6, and C is equal to 9. Now we can go ahead and substitute the values of A, B, and C in the formulas here. Hence, H is equal to 6 divided by 2 times 1. K is equal to 4 times 1 times 9 minus B squared, that will be 6 squared, all over 4 times 1. So we have 6 divided by 2 gives us 3. So H is equal to 3. Now we have 4 times 9, which is 36. So 36 minus 36 divided by 4 gives us 0. So K is equal to 0. So therefore, in the form x squared plus 6x plus 9, in the form A open bracket x plus 8 all squared plus K gives us, our A is 1, so we have x plus 3 plus 0. So that's it in the form. In our third and final method, we are going to represent our quadratic equation x squared plus 6x plus 9 in the form, the vertex form, using our algebra tiles. So here I have x squared, meaning that each side of my x is x, and these are my x tiles. So the area of these rectangular tiles are x, given that the length is x and the width is 1. So we have 6 of them. Finally, we have our unit tiles, so our square units. So we need 9 square units. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have all pieces represented using our algebra tiles. Now, what we need to now do is to complete the square, or try to create a square using our algebra tiles. So, what do we know about a square? The length and the width are equal. That means any amount of number I'm extending my length by, I will have to extend my width by. So if I have my x squared tile here, and I have 6 x's, so if I put 1, 2, 3 here, and I put 1, 2, 3 here, so my length and width must be the same. Now, what do we do with our 9 pieces of unit squares? We're going to fit them to actually complete the square. So let's see how many can fit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Lovely. We have gotten a perfect square. Nothing is missing and nothing needs to be added. So this expression, x squared plus 6x plus 9, forms a perfect square. Now, how do we put it in the form of a x plus h squared plus k? Now we're going to find the area of our square here. Now, what's the area of a square? The area of a square is length square, or L square, or you could even say length times width, because the length is equal to the width and the width is equal to the length. So how do we know the area of it? So let's find our length. So the length would be x, because we know that each side of this is x. Here is 1, 1, 1. So here would give us x plus 3. And then here now we'll have, okay, so we say here would be 1, same way, 1 again, 1, so that's 3. And the side here is x. So we got another x plus 3 here. And because area is equal to length square, we're going to have what? X plus 3 times x plus 3. And because it's the same, we can say it's equal to x plus 3 all square, which is in the form just as we have it, a open bracket x plus h all square plus k. In our next video, we're going to look at completing the square. We're going to look at using all three methods where the coefficient of our x square is not equal to 1.